Good morning, students. It gives me great pleasure to talk to you students through video presentations like this as usual. The topic which I have chosen is rate of change of quantities. Before going to the problems as usual, let us think about a particular example. Just imagine that you are walking through a road. Okay, you happen to think of a pond which has some water. There should be some enough amount of water. Okay, you will feel like throwing a stone. You won't just simply walking on the road, you just feel like throwing a stone over there. Okay, when you throw a stone into the pond where there is some amount of water, obviously with the point where the stone is being dropped at the center, we'll be looking at various ripples. We call it as ripples. Okay, various ripples as drawn over here. With this as the center where the stone is being dropped, you will think about various ripples being formed. Okay, you mean to say that it's equivalent to various concentric circles. Similar situation is counted here in mathematics. If the radius of a circle is increasing at the rate of 2 centimeters per second, and what is the corresponding increase in its, you mean to say area and then circumference, etc. you can think about. When there is an increase of 2 centimeters per second in the radius of a sphere, what is the corresponding increase in its surface area? What is the corresponding increase in its volume? Such things are to be discussed. Then what is the meaning of 2 centimeters per second? That is, every second it gets increased by 2 centimeters. For example, if the initial radius is 2 centimeters and if the increase in the radius is 2 centimeters per second, the second it will be 2 plus 2, 4 centimeters. The third second it will be 6 centimeters. The fourth second it will be 8 centimeters. That is the meaning. Every second it gets increased by 2 centimeters. That's the meaning. Then, what is the meaning of rate of change of quantity here? You have seen the notation already, dy by dx. That is the rate of change of y with respect to x. That's the meaning of dy by dx. The rate of change of variable y with respect to the variable x. In general, there is an increase of 2 centimeters per second in the radius. If r is the radius, then dr by dt. R is the notation for radius, t is the notation for second. Therefore, dr by dt here we write it as 2 centimeters per second. If there is a decrease, let us say 2 centimeters per second, I will write it as minus 2 centimeters per second. This minus sign will tell you that there is a decrease. The minus sign will tell you that there is a decrease in the radius. Okay, plus sign tells you there is an increase in the radius. Let me just repeat, by dy by dx, it is known as the rate of change of y with respect to x. By dr by dt, you mean rate of change of r with respect to t. If r is the radius, t is time, the rate of change of radius with respect to time t in seconds or meter, whatever is given in the problem accordingly. These are the basic things you are supposed to remember. Then we'll move on to the problem directly. Okay, if there is an increase of 1 centimeter per second in the radius of a circle, then find the corresponding increase in its, let us say, circumference and second summation area. Okay, circumference area when radius is 3 centimeters. Let it be. Now answer. I am supposed to give the various notations initially, then only we should proceed. Okay, let the radius, circumference, area of the circle in time t in seconds. Okay, t in seconds be I call it as R centimeters. It's given in centimeters in the question itself. R centimeters, C centimeters, comma, A centimeter square respectively. A centimeter square respectively. Okay, now dr by dt is equal to 1 centimeter per second. This is given to you. Now, formula for C is 2 pi r. Okay, circumference. Now, for dc by dt happens to be 2 pi dr by dt. Substitute the value dr by dt is 1. Therefore, this is 2 pi centimeter per second. Now, A is supposed to be pi r square. Therefore, my dA by dt happens to be 2 pi r dr by dt. Therefore, my r is 3. Therefore, this is 6 pi centimeter square per second. Therefore, I am supposed to give the conclusion wordings. Therefore, the circumference increases the rate of 2 pi centimeter per second. Okay, and the area increases at the rate of 6 pi centimeter square per second. That's what I am supposed to write down. Just listen. If there is an increase of 1 centimeter per second in the radius of a circle, then find the corresponding increase in its circumference area, and the radius is 3 centimeters. Let the radius circumference area of the circle in time in t in seconds be or centimeters, c centimeters, a centimeter square respectively. Now dr by dt is 1 centimeter per second. That is given in the problem. This is given in the problem. Okay. In wordings it is given. I am writing in mathematics. Okay. In terms of mathematics. Now formula for C is 2 pi r. For dc by dt is 2 pi dr by dt. I am differentiating with respect to t throughout. For 2 pi into dr by dt is 1. For 2 pi centimeter per second. Then what is the area? Formula for area? Pi r square. dA by dt is 2 pi r dr by dt. Okay, this is pi. Okay, this is pi, this is pi. Now substitute r as 3. Therefore, to 6 pi centimeter square per second. Therefore, I can write in wordings that the circumference is increasing at the rate of 2 pi centimeter per second and area is increasing at the rate of 6 pi centimeter square per second. 6 pi centimeter square per second. Okay, 6 pi centimeter square per second. I think it's clear. I think it is clear. Okay, we'll just take one more example. Okay, the volume of a cube, the volume of a cube is increasing at the rate of 8 centimeter cube per second. Okay, how fast is the surface area? The surface area increasing when the length of the edge is 12 centimeters. Okay, answer. As I already told you in the previous problem, I should mention the various notations. Let the edge of the cube, comma, volume, comma, surface area at time t in, it is given only in terms of seconds, t in seconds, be a centimeters, comma, volume v centimeter cube, comma, s centimeter square respectively. Okay, this is what I should write down initially. Now dv by dt is supposed to be is equal to 8 centimeter cube per second. This is given. Now what is to be found out? To find ds by dt when a is equal to 12 centimeters. Now what is the implication here? d by dt of formula for volume of a cube is a cube. This is 8 centimeter cube per second, which implies 3a square dA by dt is equal to 8, which implies dA by dt happens to be 8 by 3a square, let us say. Now formula for surface area, we always mean here is the total surface area, 6a square. Now ds by dt happens to be 12a into dA by dt. Let me substitute the value. What do I get here? It is 8 by 3a square, let us say. dA by dt is already given to you. Now 1a gets cancelled. Therefore 12 into 8 by 3 into 12. A value is given to be 12. Therefore 12 gets cancelled. Therefore this is reduced to 8 by 3 centimeter square per second. Let me repeat the whole process. The volume of a cube is increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing? And the length of the edge is 12 centimeters. Let the edge of the cube volume surface area, okay, edge of the cube, let me write it clearly, okay, edge of the cube volume surface area time t in seconds be a centimeter, b centimeter cube, s centimeter square respectively. dV by dt is equal to 8 centimeter cube per second, that is given. Required to find ds by dt when a is 12 centimeters. Now what is the implication here? d by dt of a cube is 8 centimeter cube per second. 3a square dA by dt is 8. dA by dt is 8 by 3a square. Now s is 6a square. The formula for total surface area is 6a square. For ds by dt is 12a dA by dt. 12a into 8 by 3a square, which we have already obtained here. 1a gets cancelled. 12 into 8 by 3 into 12. For 8 by 3 centimeter square per second. How do I write the final conclusion? For surface area increases at the rate of 8 by 3 centimeter square per second. 8 by 3 centimeter square per second. Surface area is increasing at the rate of 8 by 3 centimeter square per second. That's the way it's being written. I think it's clear to you. If due to time constraints, let me stop here. If necessary, I'll continue with some more problems in the next video. Thank you students for patient watching, and to have notification about further videos, better you subscribe by clicking the subscribe button as well as the bell icon. Forward it to your friends also. It will be very useful to students who are doing 12th standard of any board for that matter. Thank you. In the above recording, I have spoken about dr by dt. By dr by dt, we mean rate of change of radius with respect to time t. R is meant for radius and t is meant for time. By mistake, it is recorded as t is meant for seconds. Seconds is only the unit for time. Make the correction and learn. Thank you.